All right, continuing our notes on composition of functions, we now have a graphical representation of f of x and g of x. So when we see this notation, g of f of 0, that means we first want to start out and figure out what is f of 0. We find our f function. It's this dotted function. F of 0 would be this point at 0, which is still 0. We're taking that and plugging it into g. Well, g of 0 would be up here at positive 3. So we can rewrite this just g of f of 0 ends up being 3. Next, we're going to do f of g of 1. So g of 1 is going to be put into our f function. Let's start with that g of 1. When x is 1, g is at 4, so g of 1 is 4. And we're plugging that into our f. At 1, 2, 3, 4, f of x is at 2. So f of g of 1 is 2. Then we have g of g. You can compose a function with itself. It doesn't have to be two different ones. So g of g of negative 2 means we're going to start with when x is negative 2, where is g? And it's at positive 1. So that would be equivalent to saying g of 1. Well, now g of 1 is back at 4. So g of g at negative 2 will be 4. The last part we have is this decomposition. To decompose things, we need to think backwards a little bit. So it's going to take a few examples to get this understanding. Give me these three, and then if there are more questions, that's fine. Just reach out at that point. So we have a capital F of x function, and it is being defined as the composition f of g. We need to figure out two functions that create that composition. And the order matters, so we need to pay attention to the way it's defined. But this is saying f of g of x. So g is going inside of f. Looking at this capital F of x function, I'm going to start with g of x. And for right now, let's let g of x be the square root of x. There's a reason why I chose that, but if this function is going into f of x, then it needs to replace whatever x is in f of x. So we're going to let f of x be x plus 1. If g of x goes into f, right there where x is, you do get the resulting square root of x plus 1. In this second example, we have capital F of x is 1 over x plus 3. We're still doing the same order of composition. It's still f of g of x. So I'm going to start with whatever that input function is, f of x, or g of x, I'm sorry. And I'll look at where x is in the original function. And I'm going to start with x plus 3. If g of x is x plus 3, then that's going into this spot, which is the whole denominator. So f of x could be 1 over x, where you're putting the x plus 3 in the spot of x. All right, the third one is 3 times x minus 1 cubed minus 2. All right, I'm going to let g of x be x minus 1. If this x minus 1 has been replaced, then that means f of x is 3x cubed minus 2. And we can always double check. I encourage you to plug this back in, see if that does give you the exact same result. And this one does. But that is only one of the possible scenarios that you could choose from. With decomposition, you have some more freedom, so I'll just be checking to see if your decomposition works. So what if I had said we're going to let g of x be x minus 1 cubed? That's a different g of x function. But if that's going into this f of x, it has replaced that whole x minus 1 cubed. So 3x minus 2 would be our f of x. We can put that in the whole x spot. You do get the same resulting function. The last one, or last possible scenario that it could be, would be, let's say g of x is 3x minus 1 cubed. If that whole thing was being replaced, then all that's left for f of x to be is x minus 2. You have 3 different possible decompositions that you could use. Oftentimes the directions are going to say something a little bit more specific, like find 2 non-trivial functions. Or it might say find 2 non-identity functions. That just means that your function cannot just be x, all right? It would not be okay for f of x to be something, for g of x to just be x, because then, like in this one, your f of x would just be the square root of x plus 1. That is the same function. Nothing changed because x is going in here. It keeps it the same. That's not okay. So the identity function is when it's just x, y equals x. We want non-trivial functions. All right, there's one that I also want to include, and it's not in your notes. So let's say we have a capital F of x is maybe x squared minus 8 over 5 plus x squared. And this one, it's a little bit trickier because you have multiple x's. And if we are finding f of x and g of x, and we're still doing the same order, I'm going to let g of x be x squared. That is replacing this whole thing here in both spots. So f of x would be x minus 8 over 5 plus x. Every time we saw an x, it was replaced with x squared. All right, so if there are more questions, that's fine. You can send them to me. There are practice questions in the lab manual as well on this decomposition. Otherwise, I'll see you in class.